Yeah, good morning students. This is Patnaik sir from Railway English Medium School number 1 Bilaspur. Once again, welcome you in the online classes. Okay, today we'll continue gravitation. We'll continue the chapter gravitation. First of all, in the last class, I will explain you about the universal law of gravitation. According to this law, every particle of the object, every particle of the matter in the universe attracts the other, okay, with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Now, also I explained you about the Kepler's law. Now, today we are going to see about the free fall. ये कोई ऑब्जेक्ट है, सपोज दिस इज द ऑब्जेक्ट, इफ यू लिव इट व्हाट विल हैपन, दिस विल फॉल डाउन. व्हाई दिस? ड्यू टू द ग्रेविटी. सो a body falling freely towards the earth under the action of gravitational force alone is said to be free fall. If you leave the chalk here, what it will fall down? It is due to the gravitational force of the earth. Any body, if you live from a height, it will fall down due to the gravitational force of the earth. This is called gravity. Freely falling body. See, a body falling towards the earth under the action of gravitational force alone is said to be free fall, and such a body is said to be free falling body. Okay. Now there is the influence of the air also. What Galileo, he did an experiment. Galileo ने एक experiment किया. For example, एक बॉक्स है, इस बॉक्स से सारा एयर को निकाला. अब फेदर को जानते हो, पंख, और एक स्टोन अगर तुम्हारे बिल्डिंग के ऊपर से गिरा होगा तो obvious that the stone will drop first. Okay? क्या होगा? स्टोन जल्दी ड्रॉप हो जाएगा एज कंपेयर टू दैट ऑफ द फेदर ड्यू टू द मासेस. बट इफ यू, अगर कोई बॉक्स है, व्हाट गैलीलियो डिड एन एक्सपेरिमेंट, एक बॉक्स में इसके अंदर का एयर को पूरा निकाला, वैक्यूम, दैट इज कॉल्ड वैक्यूम क्लीनर, जानते हो ना वैक्यूम क्लीनर, वैसे, और एक साथ बड़ा स्टोन और फेदर को ड्रॉप किया. ये देखा इन द एब्सेंस ऑफ द एयर दोनों एक ही साथ. यूजुअली व्हाट हैपेंस, अगर फेदर को और एक स्टोन को गिराओगे बिल्डिंग के ऊपर से, कौन सा जल्दी गिरेगा? ऑब्वियस दैट स्टोन विल फॉल. बट व्हाट ही डिड, ही रिमूव्ड ऑल द एयर फ्रॉम ए बॉक्स, वैक्यूम कर दिए. वैक्यूम मतलब नो एयर इज कॉल्ड वैक्यूम, एंड देन ही ड्रॉप्ड दैट स्टोन एज वेल एज द फेदर, दोनों को एक साथ ड्रॉप किया. उसने क्या पाया एक्सपेरिमेंट में, दैट दोनों एक साथ नीचे गिरे. ये नहीं कि पहले स्टोन गिर गया बाद में फेदर, because air was absent, due to the absence of the air. Then he came to the conclusion that it is concluded that in the absence of the air, resistance all bodies fall at the same rate. Therefore, for a freely falling bodies, the force of gravitation produces constant acceleration. Now, what is acceleration? The rate of change of velocity. Acceleration किसे कहते हैं? जैसे तुम बढ़ा रहे हो एक्सीलरेटर जैसे बढ़ाते हो, क्या होगा? गाड़ी का स्पीड बढ़ता है कि नहीं? आइदर इट विल बी मोटरसाइकिल और कार, एनीथिंग. एक्सेलरेट, द रेट ऑफ चेंज ऑफ वेलोसिटी इज कॉल्ड एक्सेलरेशन. ओके, नाउ विल कम एक्सेलरेशन ड्यू टू ग्रेविटी. द कांस्टेंट एक्सेलरेशन प्रोड्यूस्ड इन ए फ्रीली फॉलिंग बॉडी ड्यू टू द ग्रेविटेशनल पुल इज नोन एज एक्सेलरेशन ड्यू टू ग्रेविटी. कांस्टेंट एक्सेलरेशन, when you drop it, ये continuous गिर रहा है due to acceleration. There is a change, constant rate of change of velocity. That is called gravity. Acceleration due to gravity. Generally, acceleration due to gravity को g से denote करते हैं. It is denoted by g, and the value of g is equal to 9.8 meter per second square. Okay, g is equal to 9.8 meter per second square. Now we'll see the relation between small g and v. If you want to take down this, you can take down relation between. Whenever you are having a physics period, sit with your copy, okay? Homework copy and pen. So that the important things, because I will be sending the notes, no doubt, but I will be sending through question answers when I will twist the questions, how it has to be answered in the examination, that I will send, okay? And numericals also I am sending. Anyway, relation between small g and g. Small g is acceleration due to the gravity. And capital G, universal gravitational constant. Okay. Consider a body. Consider, you can take down. Consider a body of mass m. Body of mass m near the surface. Now the magnitude of gravitational consider a body of mass m near the surface. Magnitude of gravitational force F equal to generally the force of gravitation, every object, every particle of the matter attracts another with a force having gravitational force F equal to g mm upon r square. We did it r square. Here consider a body of mass m, कोई भी body, a body of mass m, surface of the magnitude of gravitational force is given by F equal to g me, where me is equal to mass of earth and re, radius of earth. Okay, m is the mass of the earth and r is the radius of the earth. Now take down, then I will explain because I have grabbed it over. Okay, take down 1 minute at a time and do. Now, I hope that you have finished this one. Consider a body of mass m near the surface of the earth. The magnitude of gravitational force is given by the formula you know, F equal to g mm upon r square. Here I am writing F equal to g. Me is mass of the earth and mass m small m is the mass of the object upon r square. R square we write here and then r is radius of the earth. Okay. Now see here, the gravitational force produces an acceleration, okay, which is equal to g. कोई भी बॉडी है, जैसे सपोज आई एम स्टैंडिंग, इट इज if you say what is my weight equal to force, W equal to mg, mass into gravity, okay. The gravitational force produces acceleration equal to G. Now, F equal to, according to Newton's second law of motion, how much force it will produce? According to Newton's second law of motion, again, force equal to mass into acceleration equal to F equal to here m into G. Force equal to m into G. Mass into gravity. Now what we will do? Equating 1 and 2. You write this as equation number 1 and this as equation number 2. This is also force and this is also force. Now equate these two. That is equating 1 and 2. Equating 1 and 2. Force mg, we have to find the value of gravity mg equal to G me into m upon r square. Got it? Here m and m will cancel. G equal to G and E upon RE. You can see that the gravity is independent of mass. Independent mass, यहाँ mass m नहीं है, mass of the object नहीं. तो G equal to G m E upon RE square. Got it? This is the expression for the acceleration due to gravity. You write this is the expression. Or no need to write it G equal. This is the way. That means G equal to G m E upon R square. Sometimes they may ask how you got this derived G equal to G m E upon R square. Derivation बोलते हैं इसको. Higher classes now धीरे-धीरे बढ़ेंगे. How to derive the value of G? This is the method. Consider a body of mass and on the surface of the object. Obvious the object will produce what? Gravitational force that is given by the formula F equal to G m E upon R square. That is G m E is the mass of the earth and R is the radius of the earth. Also the gravity will produce an acceleration that is given according to F equal to ma or F equal to mg we write. In the acceleration due to gravity, that is why we write mg. Now equating 1 and 2, mg equal to G m E m upon R square. Here m will cancel out, G equal to G m E upon R square. That means the gravity, acceleration due to gravity is independent of m. मतलब वहाँ उसमें m नहीं है, mass नहीं है. This is that. And its value, you know, the value is how much? The value of gravity, its value is 9.8 meter per second square. Now if you go on putting the values, gravitational constant, mass of the earth and R, you will get 9.8 meter per second square. I will explain value also, how to find the value. This one take down. Finish. Now we'll see value of acceleration due to gravity. Acceleration due to gravity. This is denoted by small g. And it is always nice in the examination also, when you are doing any numerical, the value of g is not given. That it is understood that it is 9.8 meter per second square. Now see here, value of acceleration due to gravity. We know that no need to derive it. We know that you have to buy a g equal to what? Capital G m E. How much you got? M E upon R square. This value, acceleration value, now we are finding the value, how we got 9.8 मीटर पर सेकेंड स्क्वायर. कैसे आया 9.8? Now value of acceleration due to gravity g is given by the formula g into me upon r square. Now what is the value of g? G equal to 6.67 into how much? 10 to the power of 11. And the mass of the earth. What is the mass of the earth? Radius of the earth. This is millimeters. Got it? Now, how to find the value of the acceleration or the value of the acceleration due to gravity? How we get 9.8 meter per second square? We know that g equal to g, m is mass of the earth upon r is radius of the earth. This square. G is 6.67 into 10 to the power of 11 Newton meter square per kg square. M is the mass of the earth. Okay, when we calculate this one, by putting the value g equal to, put the value 6.67 into 10 to the power of minus 11 into mass of the earth is 6.6 into 10 to the power 24 upon r that is 6.4 into 10 to the power 6 square. When you calculate this one, you will get, what you will get? When you calculate the whole thing, you are getting 9 point. No need how to calculate it, let it be. Because in higher classes you will learn, no need to learn. From this you can get g equal to, when you calculate this one, you will get g equal to 9.8 meter per second square. You have to convert kg into meter. This one Newton meter. Okay. Then here meter is okay. Then you have to convert kg and Newton meter. Anyway, this one, just remember that this one, when you calculate all this, you get 9.8 meter per second square. Okay? Now it is up to you. You are in class 9, no need to convert all this. Just remember how to find the value of acceleration, how we got this value 9.8 meter per second square. Okay? Now, variation. If you want, you can take down 1 minute time and give me. Because in higher classes in physics, you will learn all this Newton, how to change it into. So, just remember that after calculating this one, you get 9.8 meter per second. Now, see G. How do G vary at different places? What is the difference between small g and capital G? Capital G is universal gravitational constant, means it is constant everywhere. Everywhere means यहाँ पर हो या मून पर जाओ, हमेशा anywhere in the, it will be anywhere in the universe, it will be constant. The value of G will be constant. But the value of small g, acceleration due to gravity, it varies from place to place. Okay? Variation in the value of g. Now this you can take down. Variation in the value of g. The acceleration due to gravity on the surface is g varies from place to place due to the shape of the earth. Earth is not round. Okay, earth, it seems like that. Shape of the earth is not perfectly spherical. It is egg shaped and its radius at the pole is smaller than that of the equator. So G increases from equator to the poles. The value of G is more at poles than at the equator. You will write G varies from place to place. From place to place due to the shape of the earth. Now see this one. First take down, then I will explain this one. Okay. G varies from place to place due to the shape of the earth. Earth is not exactly पूरा गोल नहीं है, elliptical shape. When you study in higher classes, ellipse क्या बोलते हैं? ठीक है? Elliptical shape, elliptical. ऐसा वाला shape को elliptical बोलते हैं. पूरा exactly earth गोल नहीं. As the shape of the earth is not perfectly spherical, it is axial and its radius at the poles. You must have seen in geography, you must have studied poles. Poles किसको बोलते हैं? Equator, and these are the poles, north pole, south poles. अब देखोगे, this is the equator, here the radius is. G is inversely proportional to 1 by r square. Means इनवर्सली मतलब जैसा रेडियस बढ़ते जाएगा ये g क्या होगा? कम होगा. इनवर्सली प्रोपोर्शनल टू 1 बाय r स्क्वायर. जितना रेडियस बढ़ेगा, अब रेडियस यहां सबसे ज्यादा है तो g क्या होगा? व्हाट विल बी g? द वैल्यू विल बी लिटिल बिट लेस. मींस एज यू गो टू द पोल्स, वहां रेडियस क्या हो रहा है? अर्थ का रेडियस देखो, अर्थ का रेडियस अगर कम होगा तो ग्रेविटी क्या होगा? बढ़ेगा. Therefore G increases from equator to the poles. The value of G is more at poles. तो पोल्स पर रेडियस क्या हो जाएगा? कम हो जाएगा. जब रेडियस कम होगा, इनवर्सली मतलब एक कम होगा तो दूसरा ज्यादा. रेडियस जब कम हो जाएगा तो ग्रेविटी क्या हो जाएगा? Therefore gravity value of G is more at poles. Sometimes they may ask the question, okay, why the value of G? because then you have to tell this relation G is inversely proportional to 1 by r square, and as the shape of the earth is not perfectly spherical, it is somewhat elliptical, so the radius goes on decreasing at the pole. As the radius decreases, this will increase because this relation G is inversely proportional. Therefore, G increases from equator to the poles. Okay? Take down. Second, go on, take down fast. Second, the value of G of G decreases with the height from the surface of the earth. The value of G decreases with the height from the, as you go high, जितनी ज़्यादा height जाएगा, value क्या होगा? It goes on decreasing. Third, the value of G decreases as we go below the okay. First, it goes on increasing from the equator to the poles. Second, the value of G decreases with the height. जितने ज़्यादा height on the surface, this is the surface of the earth, right here. जितना ऊपर जाओगे from the surface of the earth, it will go on decreasing. Third, the value of G also decreases when you go below the surface. अर्थ के surface से जितना नीचे जाओगे, तब भी value of G क्या होगा? Decrease होगा. Difference between G and now time is running out. I am going to explain what is mass of a body. Now see here, what is mass? Difference between the mass and the weight. What is mass? Mass of a body is defined a quantity of matter contained in the body. It is denoted by M, SI, mass. Quantity of matter contained in it. Suppose, what is the mass of this distance? अपन weight नहीं बोल रहे, weight रहेगा balance में इस रखोगे तो due to the average W equal to M into G, उसको बोलते हैं weight. Mass means इसके अंदर जो quantity of the matter contained in this, that is your mass. Mass is defined as the also defined inertia. Inertia, you know what is inertia? The mass, what matter contained in the body is called mass, and mass is a measure of inertia. So mass of a body is the quantity of matter contained in it. It is denoted by small m, and mass इसका कितना mass है? तो mass किसमें कहते हैं? किलोग्राम, kgs, 2 kg, 3 kg, 4 kg, 5 kg. That is actually mass. Mass is the amount of the matter contained in an object. Is called mass. Now we will come to weight. Now, important points about the mass. What are the important? Mass में important point. The mass of a body can never be zero. वो कभी जीरो नहीं हो सकते. इसमें कुछ ना कुछ क्वांटिटी है, कुछ ना कुछ मैटर है, तो मैटर आएगा तो वो कभी भी जीरो नहीं हो सकता. वेट जीरो हो सकता है, जहाँ जीरो W equal to mg. I will come later on. Okay. Mass of the body can never be zero. Mass of the body is constant, remains the same at all places. Mass is a measure of inertia of the body, so mass is also known as inertia mass. Mass of the body is a scalar quantity. Mass can be measured with the help of a beam balance. Mass can be measured with a beam balance. Now I will be sending what is the difference between mass and the weight. Today we have studied, time is running out, otherwise we have started the weight also. Again in the next class, I will explain again the difference between the mass and the weight, how and what is the difference between mass and the weight. Then we will come to the numericals. Okay, with this I am ending my class today. Thank you and have a nice day.